speaking. Hello, everyone. Welcome back. Good afternoon. I'm Steve.
And I'm Scott.
Together, we're Backyard Musings broadcasting in Apple Valley.
Yep. Hot again today, or the end of the day, and so we're doing it inside to save ourselves. So but we're talking science and technology. Definitely in this topic right here.
Okay. Intercrystals could pave the way toward greener electronics and next-gen quantum technologies. Scientists at Rutgers University-New Brunswick have identified a new type of material known as intercrystals, which display unusual electronic behaviors that may help shape future technologies. According to the research team, intercrystals demonstrate electronic characteristics not previously observed, opening the door to progress in areas such as advanced electronic devices, quantum computing, and sustainable materials. Would you like to know more?
The findings, published on May 6, 2025 in Nature Materials, describe how the researchers created intercrystals by layering two sheets of graphene, each just one atom thick and arranged in a honeycomb-like grid on top of a crystal of hexagonal boron nitrate, a compound made of boron and nitrogen. By slightly twisting the graphene layers, they produced, is that more?
It said moire. It's like it's French. Moire patterns. Like
Okay,
that's a pattern, a type of pattern.
Yeah. Similar to the visual ripples that appear when two fine mesh screens overlap. This small structural shift dramatically influenced the way electrons travel through the material.
So this is very small. The width of an atom, you're talking nano or maybe micro, between micro and nano, that size.
Or micro nano?
Maybe. Sounds like Cameron. But yeah, and we've talked about graphene before.
And this nanos.
And we've got a boron mine right here, right outside our town, like 30 miles away, 20 miles away.
Correct. Yep.
So it's pretty cool.
Owned by Kennecott Copper.
Yeah. Quote, our discovery opens a new path for material design, said Eva Andre, Board of Governors professor in the Department of Physics and Astronomy in the Rutgers School of Arts and Sciences and lead author of the study. She continues, intercrystals give us a new handle to control electronic behavior using geometry alone without having to change the material's chemical composition. By understanding controlling the unique properties of electrons in intercrystals, scientists can use them to develop technologies such as more efficient transistors and sensors that previously required a more complex mix of materials and processing, the researchers said.
This is a quote. You can imagine designing an entire electronic circuit where every function, switching, sensing, signal propagation is controlled by tuning geometry at the atomic level. This is according to Jedediah Pixley.
You made that name up.
I did not. I'm reading it. I'm telling you. And did you ever watch the show Petticoat Junction?
Yeah.
Hooterville, and the next town over was Pixley.
Mm-hmm.
Not making fun of his name, just saying. An associate professor of physics and a co-author of the study. Quote, intercrystals could be the building blocks of such future technologies.
The discovery hinges on a rising technique in modern physics called twistronics, not making that up, where layers of materials are contorted at specific angles to create moire patterns. That's spelled Moire with a little hot check on top.
Yeah.
These configurations significantly alter the behavior of electrons within the substance, leading to properties that aren't found in regular crystals.
The foundational idea was first demonstrated by Andre and her team in 2009 when they showed that moire patterns in twisted graphene dramatically reshape its electronic structure. That discovery helped seed the field of twistronics. Okay.
It's pretty wild. Electrons are tiny particles that move around in materials and are responsible for conducting electricity. In regular crystals, which possess a repeating pattern of atoms forming a perfectly arranged grid, the way electrons move is well understood and predictable. If a crystal is rotated or shifted by certain angles or distances, it looks the same because of an intrinsic characteristic known as Symmetry.
Symmetry. Okay. The researchers found the electronic properties of intercrystals, however, can vary significantly with all small changes in their structure. This variability can lead to new and unusual behaviors such as superconductivity and magnetism.
Oh, maybe we got another fourth form of magnetism.
Okay, which aren't typically found in regular crystals. Superconducting materials offer the promise of continuously flowing electrical current because they conduct electricity with zero resistance. Wow.
Wow, that's great. I mean, let's put some power lines made of this. Intercrystals could be a part of the new circuitry for low loss electronics and atomic sensors that could play a part in the making of quantum computers and power new forms of consumer technologies, the scientists said.
The materials also offer the prospect of functioning as the basis of more environmentally friendly electronic technologies. Quote, because these structures can be made out of abundant non-toxic elements such as carbon, boron, and nitrogen, rather than rare earth elements, they also offer a more sustainable and scalable pathway for future technologies, Andre said.
Intercrystals aren't only distinct from conventional crystals, they are also different from quasi-crystals, a special type of crystal discovered in 1982. Well, in the 80s, they were wild, with an ordered structure, but without the repeating pattern found in the regular crystals. Research team members named their discovery intercrystals because they are a mix between crystals and quasi-crystals. They have non-repeating patterns like quasi-crystals, but share symmetries in common with regular crystals.
The discovery of quasi-crystals in the 1980s challenged the old rules about atomic order, Andre said. With intercrystals, we go a step further, showing that materials can be engineered to access new phases of matter by exploiting geometric frustration at the smallest scale, unquote.
Rutgers researchers are optimistic about the future applications of intercrystals, opening new possibilities for exploring and manipulating the properties of materials at the atomic level. Quote, this is just the beginning, Pixley said. We are excited to see where the discovery will lead us and how it will impact technology and science in the years to come. I'm excited too, especially with quantum computing.
Yep, I guess it all ties together.
Yeah.
Okay.
All right, folks, thanks for joining us.
Take care, everyone. We'll see you tomorrow. Have a good night.
See you.